Hi viewers, welcome back to my channel and I'm here with another video, and in today's video I'm going to explain the answer of the questions. And what is that question? That question is how an engine knows how much fuel to inject without seeing the air. So I'm going to explain the answer of this question. So today's video is going on very interesting and knowledgeable. So you have to watch this video up to the end. At the end of this video, you will understand it so clearly that a layman or non-technical person can explain it. And answer of this question is hidden in two sensors, and that sensors are inlet manifold temperature and pressure sensor of valve loaders. We also in short they called these sensor MAT and MAP sensors. MAT mean manifold air temperature or manifold air pressure sensors. I am going to discuss about 4 points regarding these sensors. First of all, we will discuss the engine breathing analogy. Number 2, what are the MAT and MAP sensors? Number 2, how MAT and MAP sensors are working. And at the end, why ECM needs signals of these sensors. And last, the location and testing I will discuss in my next video. So yes, let's start the video, and our first point is engine breathing analogy. Think of an engine like a human body. The intake manifold is the lungs and air is the oxygen. When you breathe deeply, your body needs more energy. In the same way, when engine take more air, it needs more fuel. The sensors that tell to ECM how engine is breathing, that sensor are intake manifold temperature and pressure sensors. So now we move our second point. What are the MAT and MAP? MAT mean manifold air temperature. It measures the temperature of air in the intake manifold. Similarly, MAP mean manifold air pressure or manifold absolute pressure. It measures the pressure of the air inside the intake manifold. So yes, you know we will move to our third point. Our third point is how MAT and MAP sensors are working. So first I will talk about the MAP sensor. Inside the MAP sensor is a silicone diaphragm. When pressure increases, diaphragm bends and voltage increases. Low pressure like idle is equal to low voltage, and high pressure like full load is equal to high voltage, and these signals is between 0.5 to 4.5 volt. So you understand how MAP is working. Now we'll talk about the MAT. Now we'll talk about the MAT, how MAT sensor work. MAT sensor is like a thermistor. It measures the temperature of the air. Cold air gives high resistance. Hot air gives low resistance. And ECM supplies 5 volt to read drop voltage to know the temperature of the air. So here's our fourth and last point, why ECM needs MAT and MAP signals. The ECM not see the air. For the fuel calculation, he needs main three inputs: air temperature, air pressure, and the speed sensors. Air temperature he gets from the MAT, mean inlet manifold temperature sensors. And for air pressures, he gets the signal from the inlet manifold pressure sensors. And for the speed, he gets the signal from the speed sensor. Cold air, heavier air, it needs more fuel. Hot air is light, so it needs less fuel. If ECM get wrong air data, the fuel calculation become wrong. So ECM get the signal, correct signal from the MAT to inject the correct fuel to the engine. Normally, MAP and MAT sensor have combined four wires. One wire for 5 volt supply, second wire for ground, third for MAP signal, and fourth wire for MAT signal. In this way, these both sensors are working. If by chance 5 volt supply is stopped or this wire cut, the both MAP and MAT sensor stop working, fail to work. If these MAP and MAT sensors gives wrong data, engine lose power, black smoke appears, and thirdly, the fuel consumption increases. Sometimes code not appears, but engine performance become weak. So in this situations, we have to check these sensors. I hope you clearly understand and got the answer of these questions, how engine knows how much inject the fuel without seeing the air. If you like this video, please don't forget to subscribe my channel and share this video to your friends. See you next time in next video. Thanks for watching.